700, welcome. We are doing linear motion on an air track today, and we are using different equipment. So the way we acquire this data with the equipment we're using in the lab today is going to happen quick, but there needs to be a lot of explanation because I want to avoid any confusion that you have when you're referencing this data with the instructions provided to you in your lab manual, because of course they're referring to the other method of data acquisition. So if you were to walk into the lab, what you would have is an air track, and on that air track there are timers. They're called photo gates. In fact, there are 6 of them. So there's 6 timers approximately equally spaced out along the length of the air track. And what happens is that as your rider hits the first one, it is the trigger. It starts all the other clocks. Each photo gate has a stopwatch associated with it. So the trigger starts all these clocks, and as it passes or goes through one of the photo gate sensors, the clock stops. So after you do your first run, you will have, let's see, I believe there are 5 timers and 1 trigger. So each timer or photo gate gives you a data point. You know the position of that photo gate, and you know the time that the cart was there, hence 1 data point. The trigger doesn't have a timer on it, but you just know that is 0. You associate the clock, or the clock started at that particular point. So there's your 6 data points. Now, we're not going to use that today. Consider yourself lucky, because it's kind of a pain. With this particular lab, what you are doing is setting your cart in motion in 2 directions. So it goes across the track, say from left to right, and then you do another run where it's going from right to left. Now, when your rider goes in the opposite direction of how those photo gates and trigger was set up, that creates challenges because it passes through the trigger. The trigger is the last thing it passes under, so the times displayed on those stopwatches aren't the true value that your rider was there. You need to manipulate those readings a bit, and that's where confusion comes about. So hey, we're lucky, right? We don't have to use that today. We're using a totally different method. I guess I'm explaining this to you because I'm trying to assure you that okay, truth be told, I was looking at your lab manual, and I had to read this section about 4 times before I really started to understand what the author was asking you to do in the way of analysis. And what the problem is, what I believe is that the author assumed that you would have a table, a table that he generated and posted at the end of this lab manual, but the table didn't come out. The table, it's worthless. I don't know what happened in the printing process, but you don't see this table he provided. So there may be a little more confusion than there should be when you're reading the lab manual. But hey, maybe that's me. I read it late. Okay, let's just chalk it up to I was pretty tired. What your instructor would typically do is, in detail, go over, hey, what you're supposed to do, what you're supposed to record, how you're supposed to analyze this. So hopefully that's not an issue. Because I found this particular lab a bit challenging in the way it was presented, I really didn't want to use a different system to collect this data. It's like throwing another thing out there. Hey, by the way, I know it's kind of sketchy to begin with, but now we're going to use a different method of acquiring these data points. So I guess I'm trying to assure you that this is indeed going to make things easier with the way we're doing it. Instead of using photo gates, we're using Pasco Smart Cart. And as this cart rolls across a track, the software is picking up data. It's picking up its position and the time that it was at a particular position. Now, I could put this software on virtually whatever frequency I want. So in the span of a couple of feet, where in your lab you'd be limited to 6 data points because you only have 6 timers or 5 timers in one trigger, the Pascal software could give you 300 data points. So what I'm going to do is do the experiment with you and then forward your instructor the data that our software collected. And the data that I give you will be tabulated. For each run, however, I'm going to throw out like 20 data points. You're going to have 20 data points instead of 6. Now, you can do with them as you please. In other words, your instructor could very well rather you adhere to this to the method outlined in your lab manual, where you're constrained to just have 6 data points. If so, hey, out of those 20, pick whatever 6 you want. You know, you'd want to space them out over the span of the distance your car traveled. But yeah, just pick 6 out of the 20. Or if your instructor has you analyze this data in a more traditional fashion, where you're going to be using, for instance, software to graph these points, then you would want to just use all 20, right? So for each run, I will give you about 20 data points. And let me think. That is the only difference in the way we get data for the equipment used today. I'm trying to think if there's anything else you should know about. I think that should be it. So I appreciate you being patient and you know, listening to me describe the ins and outs of what we're going to do today. Rest assured, it's going to go quick because that's the benefit of the Pascal Smart Cart. It just, you know, we could do trials very easily, very quickly, acquire data with little error, and we'll get started. Let me put you on pause. Okay, let's do part 1. What you're instructed to do is get your card or rider and set it in motion along one direction of your track, get the data, graph that data, and determine its velocity. Then repeat the same process, but in the other direction. Now, with the equipment in the lab, you have to do it in 2 runs because your cart or rider can't pass through those photo gates twice. If it hits it a second time, all your data from the first run through will be deleted. But we don't have to worry about that with this system here, so let's just knock it out in 1 run. So here we go. We're going to get the motion across the track in both directions in 1 shot. And there we go. We just collected the data for your part 1. What I will do is provide you with 2 tables. One table will have data when this cart was moving in this direction, and then the other table will be for the cart when it moved in the opposite direction. So your analysis could be done exactly as instructed in your lab manual, although we just knocked it out in 1 run. So let me put you on pause and get this set up for the second part. Okay, so let's do the second part of the lab. Again, what you're supposed to do is set this cart in motion and get it traveling along your track in both directions while one end is elevated. Now, I think in your lab manual, it may say to start, you know, with the rider at the elevated end, release it, record the data as it goes down, then put your cart on the other side and give it a push. We can do both runs in 1 run, and that is what we'll do. Order, of course, doesn't matter, right? Okay, so here we go. That's it. We just did part 2. So what you need to know is the angle of this track. And here's how you'll do that. Well, let me give you the data that you will need to do that. You need the height of one of these risers. So what I will do is I'll put that in the grip of a vernier caliper. Now, your lab manual does a pretty good job of instructing you how to go about reading one. It's not trivial, maybe a little confusing. Well, okay, once you learn how to use it, it will be trivial. But I understand how initially there could be some confusion. This is something that your lab instructor would typically go over in the beginning of the class. There are resources out there for you. I Googled it and a ton of things popped up. So you could find anything from articles to YouTube videos on how to use a vernier caliper. So you will use that instrument to get a pretty accurate measurement for the height of these risers. So you'll be provided, along with the tables that I'm giving you, with the photograph of that in the jaws of the vernier caliper, and I'll also zoom in on its scale so that you can get even a better reading. The other thing you will need to know is the distance between these 2 feet. So what I'll do is, let's see, I'll take these feet off, and once I take the feet off, there will be holes where the feet screw in, and I'll get a meter stick and lay it across the 2 holes, and I'll put those at an arbitrary position. I'm not gonna like adjust the meter stick so that like 0 is right up against 1. That'll be up to you to get this measurement. If I were you, what I would do is measure, say, the left edge of the hole. So you would you would start with the left edge of this hole for your initial measurement reading, and measure the position of the left edge of this hole. Take the difference, and there you go. I will photograph that meter stick placed on top of these holes where the lens of the camera is like directly above the left edge of that hole, so you can get, you know, a pretty accurate reading using that meter stick. And the mass of the rider doesn't concern us. With that, you have all the data that you will need. So I'll see you next week.